Hey everyone, this is Corsair's new Thermal Protect cable. It claims to stop your GPU from melting by including a new thermal sensor in this box here that should basically cut all power to your GPU if something goes wrong. And I've been testing this product out quite a lot, and here is what happens when it works. And what I did there was actually simulate a failure case, so I actually went along and cut one wire at a time, and I did loads of testing to actually see what would happen. And by the end of my testing, I only had one wire remaining, and there was over 25 amps of power flowing through it, and then the thermal protection sensors in this actual box actually kicked in and saved the day. Go Corsair! And that's great, other than the fact that in my testing, the thermal protection didn't always seem to kick in. For example, in one of my tests, I had over 300 watts going down a single wire, and this thermal protection didn't actually kick in, even though it looked like the cable was really hot. Which is very bad and very confusing, and to be honest, I kind of hate videos like this because my brain is very black and white and I want a clear conclusion. You know, should you buy this product or avoid it? And to be honest, based on what I've seen, I probably can't fully recommend this cable right now, but it's always possible I was doing something wrong, even though I don't think that is the case. But what I'm going to do is show you exactly what I've done and all my testing of this Thermal Protect cable, and I'm also going to send this over to Corsair, and then I'll do a follow-up video in the future with any further thoughts and any comments from Corsair as well. So let's dive into it. Before showing those results though, I wanted to spend 30 seconds just going over the background just so we have the full context. So this is a 12 volt power cable, or 12 volt 2x6 because the name changed with ATX 3.1, and essentially you've got 12 wires, so 6 of them are ground wires and 6 of them are current wires or live wires. And if something goes wrong, for example if you haven't plugged this in all the way, or maybe one of the cables gets dislodged or the connector gets damaged or something, then what can actually happen is instead of all the power flowing through those 6 wires, that could actually instead mean that, you know, the power's flowing over 5 wires or 4 wires or even 3 wires. And if you've got something like an RTX 5090 that can draw like 600 watts, you could then get those 600 watts flowing down just these 3 wires. And that would be really bad because eventually those wires could get too hot, and then you could have a melting situation where the connector, you know, melts either on the PSU side or the GPU side or both. So that's where my testing came in. So in my test bench I put an RTX 5070 Ti, which only draws around 300 watts, but then I ended up cutting like 5 of the wires, so that's actually worse than like running with a 5090. So after booting up I then ran Firmark, which drew 300 watts down the graphics card, and basically then I isolated the 6 live wires by using a DC clamp meter just to check, you know, which are the live wires and which are the grounds. Although as a general rule the live wires are going to be the ones by the sensing pins, and then the ones by the actual latch are going to be the ground ones, and you can see that on the ATX specification too. And at this point the bundle of 6 wires was drawing around 26 to 27 amps of power, which is what you'd expect, because essentially you've got like 300 watts roughly from the GPU, and then you've got 12 volt power, right? So it's 300 divided by 12, which means around 25 amps, or in this particular case Firmark was actually drawing slightly more than 300 watts, which is why we were seeing more like 26 amps and not 25 amps. But essentially when we look at each wire, it was using 4.4 amps to 4.5 amps, which is actually really good and really balanced. And WAAAY done a really good video looking at the ROG equalizer cable, and on there the actual per pin amperages were completely different, so immediately the Corsair cable is ahead because the per pin amperages were very consistent. So yeah, there was no sign of melting here, and when I looked at my thermal camera, you know, there was no issue either. You know, none of the cables were looking particularly warm, and you could also touch them if you haven't got a thermal camera just to see if they're too warm, but yeah, whether I was using a thermal camera or touching them, they were fine, which is good. And with that out of the way, we could then start cutting each wire and seeing what would happen. So I turned off the computer and then drained down the capacitors just for safety, and then I cut one of the wires and isolated it with some insulation tape just for safety. And when booting back up and restarting Firmark, I could then check all of the, you know, readings again with a DC clamp meter, and this time we were seeing around 5.9 to 6 amps per pin. So some of them were 5.9, some of them were 6 amps, and some of them were 6.1, which again is fine. You know, that's not too much variation or anything. You know, that's still a very good reading across those 5 wires. And also the thermal camera was completely fine too. It can be a bit hard to see sometimes, but essentially, you know, what you don't want to see is one of the wires standing out like really orange or red, because that's a sign that it's too hot relative to everything else around it. But in this particular case, all 5 wires were looking really good, so that's all really promising. Now I should quickly say at this point that the clamp meter I've shown so far always has a negative reading. That's just due to the actual polarity, or, you know, the orientation of how I've actually held my DC clamp meter, because later on I did actually spin it around and then you see a positive value, but it's just a bit harder to film with that orientation, so I always spin it around and just have that negative value. But either way, with that first test done, we can now cut again. And then when booting back up, again I've run Firmark and I've checked the per pin amperages amperes of the 4 remaining wires, and it's 7.3 or 7.4 amps for each of the 4 pins, which again is very good. And if we look at the thermal camera view, there's also no issue there. Nothing is standing out as particularly warm. The actual heat coming out of the GPU at this stage is going to be, a lot more prominent than the heat of an individual wire, which at this stage, at 7 to 8 amps, that's not going to actually show up on a thermal camera. So next we can test again, and this time I've made a third cut on the third wire, and then we can boot up with Firmark and check the per pin amperages, and at this point we've seen 9.5 amps, 9.5 amps, and 9.6 amps. So, again, it's all fairly balanced, which is the story throughout really with this particular Corsair cable. And if you look at the thermal camera, that's also fine. We're not seeing any 1 or 3 of those wires, standing out, showing that they're going to melt or anything else. So at this stage, there's been no need for the actual Corsair Thermal Protect, feature and the temperature sensors to actually kick in. But next we can move to cut in 4 wires. And again, when we boot up and run Firmark and leave it run for a little bit, the 2 pins here are running at 14 amps and 14.1 amps, which is, way above the specification. But when I actually looked at the thermal camera, everything broadly seemed fine. I couldn't really see the 2 wires be too hot. Maybe in some of the views I could see them be slightly, orange or whatever, which basically means they are starting to get a little bit hot compared to everything else around it. But, again, the wires weren't that hot to touch. So I kind of figured that everything was okay. But I thought I'll just rerun this test another time because, 14 amps is a bit too high. So basically I turned off the computer and then rebooted after everything, had a chance to reset itself. And then I run Firmark again, and very, very quickly we had a failure. So basically the cable must have kicked in and actually turned off the, power delivery, to the GPU, which was a bit odd because I'd already run this test once before and everything seemed to be fine, and even the thermal camera wasn't showing a massive issue. But on this second test, it actually did kick in and have that thermal protection, and you can literally see, the system running fine, and then suddenly the power gets cut and the DC clamp meter goes way down. Instead of like 27 amps, it's a lot lower than that, and there's no output on the screen either. And this is what happens, as we seen earlier, when the actual Thermal Protect feature kicks in. But it's a bit odd to me that it kicked in once and not the other time. Like, I don't really understand that. But anyway, next is to actually cut another wire and run with just a single wire. And then with lots of nervousness, I actually clicked the button to run Firmark, expecting, well, either my GPU to melt or the thermal protection to kick in straight away, and it didn't. And nothing was kicking in. Literally, I had this running for around 10 minutes. And, I was Googling on my phone and, trying to work out what was going on and whether I'd cut, the ground wires, not the live ones, even though I knew I'd done it correctly. But, it just literally, this protection just wasn't kicking in, which was a bit concerning. Especially because on the thermal camera view, you can see that there's actually a major issue here. That 1 remaining wire is lit up like a Christmas tree or whatever else is orange. I can't think of a good example. Lit up like an orange. There we are. But, you can see it very, very clearly, which means that 1 remaining wire is getting very, very hot. And yet, this Corsair cable hadn't actually kicked in, even though it did on one of the 2 tests when I'd only cut 4 wires. So that was a bit confusing, and so again I shut down my system, let everything cool down. I booted back up and done another test, so again with just that 1 remaining wire. So I clicked to run Firmark, and at this point it was using around 27.1 amps down that 1 wire, and eventually after a minute and a half, everything cut off. So the thermal protection actually kicked in, and yeah, it, cut power to the system, and as a result what you actually seen was like the fans were spinning and the motherboard RGB and the RAM was actually still on, but the graphics card itself was no longer consuming power, because essentially the way this works is you've got these, sense pins here, and basically if the temperature sensor, flips, then what can happen is these sense pins are used to basically say cut all the power. So essentially, even if the PSU is sort of trying to push out 300 watts or 600 watts here, basically nothing's going to be delivered to the, GPU because the sense pins have cut off due to the actual temperature sensor triggering. That's how this cable is designed to work. So in theory, my testing did sort of show that, the Corsair Thermal Protect cable can work, because if you did have a failure condition, even on a 5070 Ti, then, sometimes the system is triggering and protecting your GPU. And ultimately, the cable I've cut up and stuff, there's no melted pins or anything like that. Everything is fine there, and I've checked my GPU and there's no melting pins there either, which is very, very good considering, I'd really abused this cable and, nothing melted. So in that case, you could argue that this Corsair cable has done its job, but you could also argue that it clearly hasn't done its job, because in 2 of the other tests, it just kept running and running, even drawing like, 27 or 28 amps down a single wire without actually, triggering any of the fail-safes, which is a bit concerning. And the reason I'm doing this video now, and I haven't yet sent it to Corsair, was that I kind of wanted to just put my, research out there and show in the tests that I've done and show all the different steps so that you can actually weigh in, and so that Corsair could as well, so they can hopefully watch it at the same time as all of you can. But yeah, what I'm going to do is do a follow-up video in the future once I've actually done a full teardown of this and hopefully spoken to Corsair and see what they've had to say. As I say, I kind of hate videos like this because I want to be clear-cut and just say, hey, this works all the time, or no, it never works, but I guess that's kind of life really, isn't it? It's messy and not always straightforward. But yeah, if you've got any comments or questions, please do leave them in the comments. I will post a follow-up video to this at some point, especially when I know more and I've done a teardown and stuff. But for now, if you enjoyed this video, please click the thumbs up button and please subscribe to see more videos like this. Thanks for watching.